Hello, a very good day to all of you. Today we are going to learn the chemical properties of amines. The first reaction we are going to learn is Hinsberg's test. This is a very important test or reaction to differentiate between primary, secondary, and tertiary amines. The reagent used for this Hinsberg test is benzene sulfonyl chloride in strong base, such as SS, KOH, or NaOH, followed by acidification. Now let us look at the reaction for primary amines in Hinsberg test. When the primary amines react with benzene sulfonyl chloride in excess of NaOH, it will form a clear solution, which is a water-soluble salt. The acidification will form white precipitate. How about the secondary amines? The secondary amines react with benzene sulfonyl chloride in excess of NaOH will form white precipitate. The acidification will show no reaction. Therefore, the white precipitate remains. For tertiary amines, the tertiary amines do not react with benzene sulfonyl chloride in excess NaOH. However, since the tertiary amine is base, it can react with the HCl to give a clear solution due to the formation of a water-soluble salt. This is the observation in Hinsberg test for different classes of amines. For primary amines, the first step will give the clear solution, whereas the second step or during the acidification it will form white precipitate. For secondary amines, the first step will give white precipitate, and the acidification shows that the precipitate remains. Whereas for the tertiary amines, the first step gives no observable reaction. Then the acidification will form clear solution. Now let us look at the second reaction of amines, which is called nitrous acid test. Nitrous acid, or HNO2, is a weak and unstable acid. Therefore, nitrous acid is always prepared in situ by treating the cold sodium nitrate NaNO2 with an aqueous solution of a cold dilute hydrochloric acid HCl. Nitrous acid is always used to distinguish classes of amines. For primary aliphatic amines, the reaction with nitrous acid will yield highly unstable aliphatic diazonium salts. It decomposes immediately and releases nitrogen gas. Therefore, the observation is the formation of gas bubbles. For the primary aromatic amines, the reaction with nitrous acid will give benzene diazonium salts. This salt is stable below the 5 degrees Celsius. The observation showed that the clear solution is formed below the 5 degrees Celsius. However, if the reaction temperature is above the 5 degrees Celsius, the benzene diazoxide salts are unstable. It decomposes and releases nitrogen gas. Therefore, the observation is the gas bubbles form above 5 degrees Celsius. For secondary aliphatic amines, it will give the yellow oil. The secondary aromatic amines will give yellow oil. How about the tertiary aliphatic amines? The reaction of tertiary aliphatic amines will form a clear solution. Meanwhile, the tertiary aromatic amines will give green precipitate. Nitrous acids is very useful to distinguish the primary aliphatic and primary aromatic amines. For primary aliphatic amines, the gas bubbles form below 5 degrees Celsius. However, for primary aromatic amines, there is no gas bubbles formed below 5 degrees Celsius. To distinguish the primary aliphatic and secondary aliphatic amines, it will show the formation of yellow oil. Primary aliphatic amines does not show the formation of yellow oil, whereas secondary aliphatic amines show the formation of yellow oils. If we give the observation in terms of gas bubbles, the primary aliphatic amines shows the gas bubbles form below 5 degrees Celsius, whereas secondary aliphatic amines show no gas bubbles form below 5 degrees Celsius. The third reaction is reaction with bromine water. This reaction is particularly the identification test for aniline. Aniline reacts with bromine water to give the white precipitate, which is called 2,4,6-dibromoaniline. The fourth reaction is formation of dye. The primary aroamines, such as the aniline, react with nitrous acid to give benzene diazoxide salts, which are stable below 5 degrees Celsius. The benzene diazoxide salts can undergo coupling reactions with another aromatic compounds which have strong electron donating group, such as the OH group, at the para position to give azo compounds. What is azo compound? The azo compounds are usually intensely colored and relatively inexpensive compounds. They are used as dyes. Now, let us look at the equations between the benzene diazoxide salt and the phenol. It will form an orange dye.